Okay, so the second half of lesson 7.2, all right, it's still going to be measuring the angles and the arcs. The stuff we did yesterday, we focused just on the actual angles themselves. What we're going to focus on today is going to be the lengths. Bless you. Okay. So the things you're going to see on circles that deal with a lot of those angles, like if you have circle graphs, if they were just to tell you what the percentages were, it would make very little sense to you. If they just said 180 degrees, okay? If I said it's 180 degrees of this circle, it doesn't really make sense. But if I said it was 50% of the circle, then it kind of gives you a little bit more understanding of how big that number is. So there's going to be times when the circles themselves, like this one, will be used as a circle graph. And they'll tell us the percentage of the circle. Or they could tell us kind of the angles themselves. But we're going to use this idea of percentages to help figure out the lengths around the outside. All right, so we'll start off, we'll kind of just use the percentages to figure out what the angles are. And then after that, we'll find the lengths around the outside. So the very first thing that I want to do to let you know on how we can figure out percentages. Or sorry, I'll let you guys finish writing that, sorry. All right, so we've got this circle again. I've got all the numbers. I've got the 7%, 9%, 26, 37, 21, all that fun stuff. If they give us percents, we can use this information from the percent to figure out how many degrees it actually is. So if they give us percent and we want to find degrees, what we will do, I'm going to write two formulas for you, or kind of formulas. We're going to take whatever the percentage is written as a decimal. So I'm going to say the percent, I'll put like underneath it as a decimal. So the percent times 360. So you're going to take the percent times 360, and that will tell you how many degrees each of them actually makes up. And at this point, you guys are good being able to convert percentages to decimals without me giving like the extra step of dividing by 100. Just move that decimal spot over 2 spots. So if they give you the percent to find the degree, you'll take the percent as a decimal times 360, and that will tell you how many degrees it is. To find the percentage, if they give you the degree, you will take your degree divided by 360, and that will give you the percent. Again, you have to move the decimal over 2 times. But again, if they give you that one, that's what you use to figure out the degree. If they give you the percent, if they give you the degree and you need to find a percent, that's what you will use in the bottom. Okay, finding the percent, will be helpful a little bit later as well. All right, so I'm going to get out my handy dandy highlighter here again. So this first one says, I want to find KL. So looking at this, I'm going to find KL. So K starts here, L is down there. All right, it gives me that segment is 21 degrees. So I'm just going to write that down there so I can have it so I know what I'm looking at. KL is 21%, not degrees. So KL is 21%. I want to find out how many degrees it is. So I had that formula. Hopefully you guys had it written down. To find the actual degrees of KL, I will take this percentage, so 0.21 times 360, because that's how many degrees there are. So I've got 0.21 times 360. So if I were to actually make that or get my protractor out and measure how many degrees it is, that one will be 75.6 degrees. Making sense? Ish. All right, let me get my highlighter again. I'm going to have you guys talk me through this next one. Okay, this one says I want to find NJL. Remember, it has to go in order, and I can't go back over itself, so I go from N to J to L. I want to know that whole entire thing, that major arc that goes all the way around. So first thing I need to do is figure out what percentage of the circle it is. Thoughts? How do I find that? Add them all together, yeah. Add everything together. Okay, so I'm going to do that. I got 26 plus 21 plus 37. Plus 37. So 26 plus 21 plus 37. I know that all of those together are 84% of the circle. To find how many degrees, somebody talk me through what's my next step then. Kaylin?
Wait. 0.84
Fantastic. Yep, I'm just going to write that percentage as a decimal. So 0.84 times 360, because that's how many degrees there are in a full circle. And I get 302.4 degrees. Again, if they give you the percent, change it to a decimal, and then multiply by 360. Thumbs up, thumbs down. So great. Okay. To be honest, I'm not going to go too much into this postulate because it just says if there's two arcs next to each other, you just add them together. We've been doing that for the last day and a half. Okay. However, I'm going to start with this one just to point this out real quick. Oh. So for this one, I do want to kind of explain one thing going back to like the vertical angles. You see when I have these two together, how this angle and then this angle are going through? Those are both vertical angles. You guys notice that? That means that this angle here is going to be the exact same as this angle here. Yeah? Does that part make sense? Likewise, this angle here, so both of those together will be the same as those ones right there. So I'm just going to kind of talk this one without having to scroll down to those ones. How many degrees is this angle right here? 90, because you got the little square, and that one's 32. So how could you figure out what this bigger section is down here?
Add 90 plus 32.
Perfect. 90 plus 32, I get 122 degrees. Okay? You already told me this was 90. To figure out this missing degree, now I can find this angle over here. Again, this is a diameter. Half circle,
180.
semicircle. 180 minus?
122.
Yeah, 180 minus 122. And I get 58 degrees. If this one's 58, what's this one? 58. Again, if you can figure out those vertical angles, you got this, and I'm not going to spend a whole bunch of time just going crazy on that. You know that the angles are going to be kind of vertical with each other, and then once you can figure out the angles, you just get to add everything up. This chapter wants you to spend a whole bunch of time just doing those same pieces there. Okay? On to the very last kind of main piece of information. Okay? I'll zoom in a little bit, and I'm going to explain this one in simpler terms here. But to figure out the arc length, so the length of the actual outside of the circle, okay? When we do that, you're going to measure from one part of that angle, measure from there, all the way across the top. Here's the formulas, but let me explain what's going on in simpler terms, and then you can write that formula down if you want. Okay? So let me just kind of explain what's going to happen first, and then I go through. All right, so if I have a circle, let's say here, and I go all the way around it, what was the fancy term for the distance around the outside of a circle? The circumference. Okay? Okay, the circumference is that entire distance around the outside of the circle. Okay, when we have that little percentage, that little sliver of a circle, we don't need to go all the way around the entire circle. We just want to go across a portion of the circle. And the way we can figure out the portion of the circle is by using a percent. Excuse me. So if we have like a percent of the circles, like if this was 90 degrees, this is also going to be referred to as 25% of a circle, right? From what you know right now, hopefully what you know, we're going to say the circle is, I already did that one. 90 degrees is going to be 25% of a circle. If the circumference of my circle, we're going to use a real simple number here, is going to be 100. We're just going to say it's going to be 100. So my circumference is going to be 100. If I wanted to find the distance of just this part, how much of the circle am I actually looking at? 25%, right? I'm not looking for the whole entire thing, I'm just looking for this one. So to figure out that little sliver, all I'm going to do is I'm going to multiply. So I'm going to say multiply the circumference times the percentage. If I multiply the circumference times the percentage, that's going to give me the arc. My arc length. So yeah, you figure out the circumference and then you multiply it by the percent, and that's how to get the arc length. This stuff up here, if you want to use the formula, you can. But what those formulas are doing is they are just putting down for you this thing right here is the circumference. That's what that formula is. 2 pi r is the circumference. Okay? The length will be the distance. And it's going to equal that percentage. Okay? So that's where this thing is going to come into play. You're going to find a percentage of 360, and that's going to give you the length. Does that make a little bit of sense? Those formulas seem confusing, but hopefully you can kind of visualize. We're not doing the whole circle, we're just trying to find a chunk of that circumference. Does that make sense, or am I confusing you guys? All right, we're going to do some of those ones. And again, you can use that formula if you'd like. We'll do the formula for one of them, and then we'll do the kind of the other way together. But again, that equation is going to be my length. So that arc length is going to equal x divided by 360. So I'm finding percentage times the circumference. So it wants me to find the length of AB. It wants me to find, let me get a different color pen. It wants me to find this distance here. So the first thing I'm going to do is I will convert that 45 degrees into a percentage of the circle. To do that, I will take 45 divided by 360 to get my percentage. That's my percent right there. Okay. The next part, I'm going to multiply that times my circumference. How do you get the circumference? 2 times pi times r. Perfect. Good job, me. 2 times pi times r. I'm going to take 2 times 3 times, and I'll say pi right there. I'm going to go through each one of these steps just to kind of simplify it underneath it. 45 divided by 360. That one gives me 0.125, and I'm going to leave it as that decimal. So yeah, that section's 12.5, but I'm going to leave it as a decimal. So I got 0.125 from this. Now I'm going to multiply 2 times 3 times pi. So 2 times 3 times 3.14. So 0.125 times 18.84. It does want us to go to the nearest hundredth. And now I just get to multiply these two numbers together. It's 18.84 times 0.125. If you have a basic calculator, just know that pi is 3.14. If you want to use that button on your calculator, you can. But 0.125. So the distance of that arc, so the distance of AB is going to be 2.34. So AB is going to be 2.34. The other thing to note, when I was looking for the angle, I used like the letter M in front of this. If I'm looking for a distance, it's just going to give me both the letters with a little arc over the top. All right, I'm going to have you guys talk me through example 2. It wants me to find AB again. So it wants me to find this distance here. So somebody talk me through how I'll set it up. How about this? I'll break it into 2 spots. I want to find the percentage, times the circumference. Anybody, what will I put for my, how to get the percentage? Any thoughts? Perfect. I'm going to divide it by 360. Which number? The 80. Fantastic. So 80 divided by 360. I'm going to times that, or multiply that by the circumference. Do they give me the radius? No, they give me the diameter. But you can figure out the circumference of the diameter, right? It's just, yeah, so the radius is going to be 7. So 7 times 2 times pi. Okay. 80 divided by 360. I'm going to just punch this stuff in the calculator. You guys can do this. Is going to be 0.22 times 7 times 2 times pi. So 7 times 2 times 3.14.
Why do you times it by 2? Yeah.
What's that?
Why do you times it by 2?
Because I need the diameter.
Okay, so then why couldn't
You could have just left 14.
Okay.
Yeah, if you wanted to leave it as 14, you could. If you wanted to stick with that same formula and just every single time do radius times 2 times pi, you could do that. But from yesterday's, like, there was a two-way to figure out the diameter or circumference. It's either diameter times pi or 2r times pi. Either way is good. It's all I'm looking for is you to figure out the circumference and the percentage. Okay, so I've got 7 times 2 or 14 times 3.14. I get 43.96. And then it just turns into both of those getting multiplied together. So the distance for AB should have equaled 9.67. Okay, I want you to do this next one all on your own. And then if you guys got that, it'll be homework time, I think. That's the circumference.
Oh.
You just have the one step after, but yeah, that circumference was key though. Yes, ma'am. Yep. Not quite. You forgot to multiply by 2. 2 times 8 times 5. So it's 2 times pi. Sorry, 2 times the radius. So this one gave us 14, so we just divided by 2. That's what we got. 7. The radius.
That came like it's a little calculation.
So,
I
I'm really worried. I go back.
Me too.
You did it?
She yelled.
What she yelled at you guys for?
Over skirts.
Yeah, your skirt's kind of.
My skirt's getting short.
Yeah,
She's the one, she talked about me when she was telling us the story about how she was walking up the stairs behind someone in her skirt was short.
Oh, yes.
I feel
I
like
didn't see the
you
one.
actually.
Yeah.
You saw six.
Pull your shirt
Yes.
I ruined it for everyone, guys.
I was in your butt.
Yeah, dude.
So-
Too bad, Brady.
All right. Hopefully you guys had this one. I'm going to do the two different parts. You should have had the 120 divided by 360 times the circumference. So you should have had 0.33 times. It would have been 2 times 8 times pi. So that would have been like 50 point something or other. 50.24. Okay, 50 times 0.33. So 50.24 times 1/3. Here's where things got a little bit weird depending on where you rounded, and that's perfectly fine. You should have had like around 16.75. Some of you did for this one. You just did 0.3 instead of like 0.333, which is going to give you just a little bit different number based on the rounding, but you're still going to be good within that margin of error. Okay, as long as I can see what you did. Thumbs up, thumbs down. How you guys feeling? Okay. Stuff I have for you guys today. I want you to do numbers 26 through 40 evens only. Sorry, page 711.